What's your question?
Okay, so from the previous, just this recent one, I think
Mm,
that was Wednesday.
yes.
You there was a question on um they said a ball is projected upwards at 20 meters per second. How long does it take to reach its maximum point?
Yes.
But then in the solution, you solved for the height. So I wanted to
Okay.
ask if the question wasn't asking for time rather.
Yeah, it was asking for time. Then we lost that.
Yeah.
Kennedy, are you there? So the question was
Yes,
asking for
please.
how long. Then we were solving for how high, right?
Yeah.
Okay. Thank you for bringing that to our attention. But you got the whole concept, right?
Yes, yes, I
Okay,
did.
sure. So today, are you aware that today we are just coming to solve questions based on the ones that you say you watch?
Yes, please.
Okay. Kennedy, are you ready?
Yes, please.
Okay. So this is the first question that we have today. Basically, a mango falls from. So I have a lot of the questions. So I'll go 10 by 10. Kennedy, Millicent, then you will tell me like the steps. I will just be the student that will be following. And then if anything that we are missing, I will just guide you. So a mango, I'm going to basically start with Kennedy first. So this question, Kennedy will take it. The next one, um, Millicent will take it. Then we see how we go about. Are we fine?
Yes,
Yes.
please.
Okay, good. Now, a mango falls from a tree branch 5 meters above the ground. How fast is it moving just before it hits the ground? So what should I do? Kennedy, yeah.
Okay, so say we are going to bring out the key points or our
Parameter,
key points,
parameters, right?
our parameters.
Okay,
Yes. So first we have our height to be 5 meters.
okay.
Then our acceleration due to gravity is 10 meter per second square.
Is it positive or negative?
Positive.
Millicent, do you know why it's positive?
Yes, please.
Okay, tell me.
Because it's coming down in
Okay,
the
the
yeah,
in the direction of the force of
the
gravity.
direction of the yeah.
Good, good. Next one.
Then since it just started falling, so we will take our initial velocity to be
To be what?
zero 0 meter per second.
Okay.
So now we are going to use the formula h is equal to.
Wait. What are they looking for? You have to also note what they are looking for.
They are looking for the time.
Read the question.
A mango falls from a tree branch 5 meter above the ground. How fast is it moving just before it hits the ground?
So what are they looking for? Millicent, what are they looking for?
Use the speed.
Which of the speed? Which of the speeds?
Please, I don't get it.
You say they are looking for the speed, right?
Yes.
And in the equations of motions, right? Basically, the speed is the
Yeah.
velocities, right? And then
Um,
we there were two of them. What are they?
okay, the initial and the final velocity.
Okay, and I'm saying which of them are they looking for?
The final.
Sure. Kennedy, do you get it?
Yes.
How fast? Okay, Kennedy, you can continue.
Okay, so we are going to use the formula v squared is equal to u squared plus 2gh.
Okay.
Then when we put in our parameters,
Okay, let me
we
put them
have
inside for you. So
this.
0 squared
Okay.
plus 2 times 10 times a, which is 5. So v squared equals to what's that? 100. Am I? Yeah, 100. right? So V is equal to what? Is that correct?
Yes, please.
Good. Um, yeah. So that was good. That was good. So read the question. So you have to, when you're writing the parameters, also write down the things they are looking for, so that you guide you to all guides you which equations to use. Let's go to the next question for Millicent. Millicent, can you take it, or Kennedy should still take it? Or maybe her network is disturbing her.
I can.
Okay, let's go.
A brick is dropped from the top of a 45-meter building. How long does it take to hit the ground? So the height is 45 meters
Okay.
and the initial velocity is 0.
Why is it zero? Do, do you know why it's zero?
No,
Okay. Kennedy, why is it zero?
Sir, it's zero because the brake was dropped from the top. So it just started falling. So
Falling.
it's going to start from 0 meter per
Yes.
second before it increases its velocity.
Okay. So Millicent, let me help you. What happened is that, yeah, that's what Kennedy said. The thing was dropped. So
okay,
meaning the person just releases it at a point in the air. So they didn't apply any particular velocity to it. They just drop it, and the thing began to fall on its own. So initially, no velocity was given to it. It was just falling down by the force of gravity. Do you get it?
yeah,
Yeah. So yeah. Okay. Next.
okay. The G is 10 meter per second.
Good. When they don't give it to you, it's 10 meters per second squared. Okay.
Yeah, and we are finding T.
How long? Okay. Yeah. Yeah, it's true. See. So which of the equations are we going to use?
We will use um.
Should I write them down for you? Or you have them over
Yes,
there?
I'm looking for it.
Okay, let me write them down for you. Oh, Kennedy, help me. Oh, Millicent, are you ready?
No, please.
Okay. Kennedy, help me with the equations again.
Okay, to say we are going to use
No,
H is equal
I
to
mean all the equations, the three equations.
okay. So we have the first one to be V is equal to U plus GT. Then our second one we have H is equal to UT plus half GT squared. Then our third one is V squared is equal to U squared plus 2GH.
Okay. Okay, so Millicent, these are the basic three ones. So which of them are we using? Millicent.
We will use the second one
Why so?
because we have H, we have U, and we have G. We are finding T.
Okay. So we are going with the second one. Is that okay for Kennedy? Is that
Sir,
correct?
yes, please.
Okay, so let me put in the value. So you have 45 will be equal to, I will need your calculators here because I think that value, there's a square something. So I don't know. 0 times t plus half times 10 plus t squared. So this t will go. So you have 45 equals to half times 5, that will be 5t squared. I will not need calculator. So t squared will be equal to 9. This means that t is equal to 3. Is that correct?
Yes, please.
Millicent, is this the final answer?
Please, I don't have my calculator.
But okay. um how do you say it? I'm not saying that. So we got this final answer right now. We got the answer to be, if we put in the calculator, you finally have t equals to 3. Is this correct? As in, um I'm actually looking for the unit basically. So Millicent, what's the unit?
Seconds.
Yeah, so 3 seconds. So when you are done, final answer of we are looking for, remember to add the unit. If not, it will not be correct. So yeah, Millicent, well done. Let's go to Kennedy. Kennedy, this is your question. What initial velocity must a basketball be thrown vertically to reach a height of 8 meters? Kennedy, are you there?
Yes, please.
Okay, I'm ready when you are ready.
Okay, sir.
Okay.
So my first parameter, I
Mm-hmm.
got our height to be 8 meters.
Mm-hmm.
We don't know our initial velocity.
Okay,
So
so I'll do u
our,
equals to not known.
then since the ball is going to head upwards,
Mm-hmm.
our final velocity will be 0 meter per second.
Okay, come again with that. Come again with that.
I said
Mm-hmm.
since the ball is going to end for some time upwards,
Mm-hmm.
the final velocity will be 0 meter per second.
Yeah. Millicent, did you capture that?
No, sir.
Okay. So you see, when you throw something into the air, right, the thing will go and to get to a point where it will temporarily stop before turning towards the earth, right?
Yes, sir.
Yeah. So where it goes and stop at the top. So basically, at the point where it stopped at the maximum height, that's the maximum point it can reach. So at always at the maximum height, the velocity is always 0. So at the maximum height, the final velocity is 0. At maximum height, when you throw something from down towards the top, the maximum height, uh, final velocity is 0. Take that as a keynote. Are we okay?
Yes, sir.
So that's why in this question is what initial velocity must a basketball be thrown vertically to reach a height of 8 meters? So there's a maximum height of 8 meters. So once there's a maximum height, at that maximum height, always at a maximum height, there is a final velocity of 0. So you take note of those things. So that's why he said that. Kennedy, is that not it?
Yes, please.
Yeah. Hello, Robert. Can you hear us?
Yes, sir.
Okay. You can um off your camera so that the internet connection can help you at that end.
Pardon?
You can off your camera, your video, so that this thing will help, the connection will help you there. Sometimes it's,
Okay.
yes, sure. Okay, so Kennedy, then what's the next step?
Okay, so since we've gotten out all our parameters, we are going to pick the formula to use.
Which
We are going
formula?
to use the formula v squared is equal to u squared plus 2gh.
2gh. Militant, are you convinced that we are accepting this equation? Are you convinced?
Yes, yes, sir.
Good, good, very good, very good. That's progress. So okay, then since he has given me the value, let me just change the values for him. So we are looking for u, that's what we are looking for, plus 2 times 10, oh, negative 10, 2 times negative 10 times 8. So that will give me, so that will mean that I'll have, let me push this thing. So that will be 0 equals to u squared minus 160. That we got 2 times 8, that's 16. That will be minus. So basically, that will give me u squared equals to 180. If you send a 180 to the other side. Then if you find square root of both sides, square root of 180, who has a calculator there? Is square root of 180.
Sir,
Mm.
sir,
Yes.
sir, please. The value is 160.
Ah, okay, sorry. Yeah,
Sir,
it's 160.
we are finding square root of 160.
Yeah, thank you. Thank you very much. Robert, thank you very much.
You are welcome.
Yeah. So what's the answer? Who has the calculator or something?
Sir, okay, let me do this.
We are waiting for the calculators.
Sir, the
Yeah,
final answer was U is equal to 12.64.
0.64. So I should write 12.64. Is that correct?
Yes.
Meter per second.
Yes, meter per second. Kennedy, don't forget the unit, okay?
Yes, sir.
Yeah. So final answer, always remember to add the units. That was well done. So we'll solve one before we give the next one to Robert. But Robert, have you been able to watch the previous video in order to catch up?
No, sir.
Okay.
But I understood.
Okay, sure, sure. So now let's go to the next question. Millicent, so take your time. Let's solve this one together. Yeah, Millicent, let me read the question for you. A ball takes 2.5 seconds to reach its maximum height. How high did it go? A ball takes 2.5 seconds to reach its maximum height. How high did it go? Millicent,
Sir.
yeah, yeah. I'm ready whenever you are ready.
Okay. The T is 2.5 seconds
Okay.
and V is 0.
V, which of them? U or V? U or V?
V. V.
Okay, V is equal to 0. Okay, that was well caught. Why did you say 0?
Because at the maximum height, V is
Ye-
0.
Very good, very good, very good. Let's go. Is that all?
And we are finding, no, we are finding H.
We are finding H.
Yeah,
Okay,
G is negative 10 meter per second square.
very good, very good. Okay, so now what's next?
We are using we are using
Take your time to select the equation.
okay.
Kennedy, is that all the parameters though?
Sir, please, it is left with the
U
initial velocity.
Initial
okay.
velocity.
U is also 0.
You said
U
U as down
U
what?
is also
Millicent, what are you saying?
please I said U is also 0.
Oh, U is also 0. Oh, Kennedy,
Um
how? Why will we?
Sir,
Yes.
to me, U is also 0
Why?
because when to me, the initial velocity was not given.
Mm-hmm.
So we'll consider that the ball started with an initial velocity of 0.
Oh,
We
okay.
consider, sir,
Yes.
sir,
Yes.
U is 0 because the ball started from rest.
Okay. 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 Guys, let me clarify something. So let's take it as a real example. This is a reality. So can you just hold a ball in your hand? Let's say a ball in your hand. Then they are saying that the ball has taken 2.5 seconds to reach a particular height from the ground. Is it possible that without you giving it any velocity, the thing will be able to reach up. Do you guys follow? Do you guys follow?
Yes, please.
Yeah.
Yeah. So
Yes, sir.
it's not possible. If the thing is coming from going from the ground to the top, we need to there is always a initial velocity, but they didn't tell us, they didn't give us in this question. But if the thing is the other way around, where so when you are going from down to the top, the final velocity is zero. That will be the maximum height. But if you are going the other way, where you are already starting from the top and you are coming down, that's when u will be zero at that point and v will be unknown. So it says twist between v and u. So let me just draw. So we are on the ground here. So if the direction that we are focusing there, so just take it like particle, we are trying to reach this particular height h. So before something can move to the from the down to the top, it cannot be done by magic. We need to supply a velocity. At that point, there is a u value will be given. But we know that at the maximum height, final v will be zero. But if the motion is such a way that they are saying, oh, now it is from the top to the down, then our u now will be here and our v now will be here. So v will be known, but u will always be zero. So the starting point when you are coming down for a free fall, when you are freely releasing the thing, when you are releasing the thing, you are not applying initial velocity, u is equal to zero. Do we understand that? Is, was I able to help you clear the confusion?
Yes.
Yeah.
Yeah. So in this particular question, the thing was going from down to top. So there's supposed to be an initial velocity, but they didn't give us in the question at all. So there is nothing here that so they can ask us in this question to find the initial velocity. So because we don't know it, but then the question is actually just looking for the height, and the parameters that we have so far are good. So yes, so let's not confuse the question. So when you are reading, first understand the question before you need. So these parameters are already in now because they are looking for height. Looking for height. So we need to look at the equation that can help us find the height. Are you good?
Yes, sir.
Yeah. So Millicent, can you continue? Can you find the equation for us? Oh, is her network, is she there?
Yes, please, I'm here.
Okay. Have you be able to select your the question? The
The
equation.
equation.
Kennedy, you raise your hand.
No.
Sir, please. You said when we are choosing the equation,
Mm-hmm.
only one variable has to be unknown.
Yes.
But in all the equations, the initial velocity is constant. And if we pick the first equation, v is equal to u plus gt, our u and t is unknown. Then the
Oh no.
second
T
equation,
T is
our
known,
h and
right?
u is
T is
known.
known.
Please, yeah, please.
So final V is equal to U plus GT, right?
Yeah.
Then H is equal to UT plus half GT squared. And then the last one
Yes.
is
V square
V squared is equal to
U
U
square
squared plus
plus
2GH.
2GH.
Now, this is what the thing is. If you pick this equation to find the H directly, you have to meet u first. If you take this equation, you have to make sure that you know u. So you can take this equation, right, to find u. When we are able to find u from this equation, we can use that u anywhere. Do we understand?
Yeah.
Yes, sir.
Yeah.
Yes.
So this particular question was to let you understand that yes, the first question that we saw were about how do you go about solving when you get the parameters. You can easily see the equation that you can pick, but most of the thing is that you can do a mix of them. Okay, these are the parameters I have, and I want to find h. But before I find h, I need to know u. So which equation can help me know u? So you look at this one. So first, actually, for this question, you need to go between two equations. So the first one is to go here first, right, to find u. Then when I know you, then okay. Once I know you, then I can come back and use my normal equation. Are we clear?
Yes, sir.
Okay. So let's find u first. So yes, someone is raising their hand. Yes, Kennedy.
Say, please, when we find the u,
Yes.
can it also be possible to use two, like you can use the second or the third equation?
Yeah, you can use any of them to help you solve any of the h, whatever h is, right? Okay, so that's it. That was very smart. You can use any of them. So the thing is, yeah, we wanted to find h. This equation could have helped us, or this equation could have helped us, but in any of them, u is needed. But then we need to go back to use. We need to find a way to find u first before we come back to find our h. So basically, we use the first equation to find that will be 0 equals to u plus gt. G is what? G is negative 10. So that will be negative 10 times t, which is 2.5. So if you do this, you are going to have u is equal to 25 meters per second. You see, there is an initial velocity of 25 meters per second. Are we good?
Yes, please.
Now that we know you, Millicent, are you there?
Yes, sir.
Okay, now that we know you, then you can decide to choose any of the equations. So the simplest one is to use this guy. So that will be h is equal to ut. U is now 25 times t, which is 2.5, plus half. And we know g is what?
-10.
Yeah, g is negative 10. And then t was 2.5. This one, t 20.5 squared. We need a calculator here. So while someone is doing that, Millicent, is it clear how we go about it?
Yes, sir.
Okay, sure. Robert, is it clear?
Yes, sir.
Kennedy, what about you?
Say, it's clear.
Yeah. So when you have the three equations and you have your parameters, that's why you write your parameters and what they are looking for. You write them down. Then you now play with all the three equations. Okay, I want to find this, but before I find this, I need to go and find this value from somewhere. So you go and find it and come back to your equation. The questions always run like so. Know how to play around the equations, then you'll be cool. Physics is basically not hard, right? And then some of the analogy that you have to know, like if you're throwing something from ground to the top, there's always initial velocity of u, but the maximum height, the final velocity is 0, and there's always a g given to you. G can be 0, g can be negative or positive based on the direction that you are going. All that we've explored that in our videos, and then those are the concepts, right? Yeah. Do you have any answer so far? This one give us what? Who is anyone trying it with on the calculator?
So we are going to have 25 plus.
No, this is times 25
Okay,
times
25
2.5
times 3.5.
plus half
52.5.
is what?
25 times 2.5, 52.5.
52.
62
Okay, 62.5. Then this one minus, I
minus
think,
31.525.
31.25. Okay, so then what do we have?
Yeah. So now we are having our final answer to be 31.25.
31.25.
Yes, sir.
Okay. Who else has tried it and has gotten this answer? Kennedy, do you have anything there?
30, yeah, 8 is 31.25.
Correct, correct. Millicent, you say your calculator is not. Do you have it now?
No, sir. But
Okay,
I
sure.
calculated.
You said?
I got the same answer.
Okay, wow, well done. Wow, that was magic. Me, I'm not good with I'm not good mentally. I'm just going with I like going with calculator all the time. Then you are very sharp though. So the next question, Robert, can you take the next question for us?
Okay, sir.
Okay, let's go. The question says a ball is thrown downward. A ball is thrown downward from the top of a 40-meter building at 5 meters per second. How long does it take to hit the ground? A ball is thrown downward
Okay.
from the top of a 40-meter building at 5 meters per second. How long does it take to hit the ground?
So coming when the ball is coming down, our initial velocity u is 0.
Uh, hmm, guys,
Yes, sir.
okay. So let me clarify. Do you all agree that the initial velocity is zero?
Yeah.
Yes, please.
Millicent, what about you? Is she there?
Sir, sir,
Yes.
I want to make a clarification.
Okay.
Sir, I wanted to ask that since they said a ball is thrown downward from the top of a 40-meter building at 5 meters per second,
Yes.
will the initial velocity be the 5 meters per second?
Oh, it's a question we are exploring, right? That's what I'm asking you guys.
Sir.
Yes.
So now our u is 0.
Okay, I'm coming. Millicent,
Yeah.
what do you think?
Yeah, our U is 5 meters per second.
Okay.
That's what I think.
Okay. So now, this is the thing, right? For coming down, there are two things that you need to keep in mind. So let me go again. If you are sending something up, always, if you are sending something up, always you need a U. Okay, before you can send anything upward, like you can do, even you have to jump, you have to make sure you apply a particular velocity, you go up. Always you need the U when you are going up. Now, when you are coming down, there are two things. Either the body is there and begins to fall like that without any initial velocity applied to it. That's one case. The other case is that yes, the body is coming from a particular height, but then imagine you are at the top. Usually, um, let's say you are on top of a building, and then you want to hit a bed that is on the floor, a floor very down there. So you use your stone and you apply velocity already at the beginning, even though you are from a height. But then normally, if you leave it like that, it will fall with its own normal velocity. That's one case without applying any initial velocity at the top, from the top. The other case is that you are not just leaving it or you are not just dropping it, but then at that top you are actually giving it an initial velocity. Do you see the difference?
Yes, please.
Yeah.
Yes, sir.
So if the person is dropping it, if in case where the person is dropping or the person is just falling or is left to fall or yeah is left to fall, then that u is equal to zero. That's it for the dropping and or just um yes, free fall. But then it's not that it's compulsory. Sometimes somebody might give it an initial velocity already from the top. That one, then you work with the velocity that they have given you. Are you okay? Yeah. But
Yes,
then
please.
if you are going from down to top, you don't have any excuse. You have to always give it a velocity. You cannot supply a zero velocity and expect it to go up. That one, there is no zero velocity. Yes.
I say Ebi,
Is someone calling me? Okay. So but then I want to be sure. Do you all get it?
Yes, sir.
Yes, sir.
Good. Kennedy, is it clear?
Yes, sir.
Sure. So in this case, yes, if the thing is dropping, all right, but then they have given it the initial velocity. So let's be careful about that. So you see the way we solve our questions, we need to make sure that we solve from very simplest one. We solve simplest questions first. We make sure everybody get the basis before we move on and be adding the one that WASI might likely give you, the true one that they might likely give you, so that we can explore them. So in this case, what's happening is that the initial velocity u is supposed to be zero, but we realize that nah, it's dropping, it's zero, but then the person has applied an initial velocity at 5 meters per second, so u is actually 5 meters per second. Okay, Robert, so you can continue.
Okay, sir. So, and our age is equal to 40 meters.
Okay.
And our final velocity. Share it online. will be 0.
Do we all agree that it will be zero?
No, sir.
No. Millicent, what do you think?
No, no, sir.
Okay. So um who will clarify to us why it's not zero? In which case do we have the final velocity to be zero? In
When the body is going upwards.
when the body goes up and reaches its maximum height, right?
Yes, sir.
That's when final velocity is zero. But when you are coming down, final velocity doesn't become zero. Is it too much for you guys? Is it too much, or should I still explain?
No, sir.
Okay, Robert, does it make sense?
Yes, sir.
So yeah, so when you are falling down, it's not this one they even giving it to us. So this one is not even given in the equation. So the parameters, right? There are some hidden parameter that you are not calling. Robert,
Sir.
yeah, there is some hidden parameter that you are
Okay,
not
so
calling.
our G.
Yeah,
Our
G
G.
is what?
10 meter per second square.
Negative or positive?
Positive.
Why?
Because the body is coming down.
Okay, sure, sure. Good, good.
Square. Meter per second square.
Yeah, it's true. So what's the next parameter? What's the next thing? What are they looking for? Um, Robert, what are they looking for?
So now they are looking for the height.
Read the question. You have given us height already, oh. So they cannot be giving us height that they have given us already.
I said, how long does it take?
Yeah.
Okay, so now they are looking for the time.
Yes, yes, yes. Sometimes it confuses. Yeah, how long? So you may think like distance or something, but it's actually time. How long will it take? So it's actually time. So basically, they are looking for time. Okay. So which equation are we going to use then?
The first equation.
Which is what?
Which one? V. Which one? Equals U plus H. Okay, yeah. Sir,
Yes.
this we can't because we are giving height, so we can't use the first equation.
So what equation are you using?
We can use the second equation.
Which is
H plus equals UT
yes.
plus half
Mm-hmm.
GT square.
T squared. Okay. Um, is that your final answer? Is that your final equation? Are you sure? Robert, are you sure?
Yes, sir.
Okay, let me ask Kennedy and Millicent. Kennedy, do you agree?
Yes, sir.
Millicent, what do you think?
Yes, sir.
Good, 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 good. Yes, so that's the equation that you use. Robert, so what happened is that when after the class, right, you take time and go and watch the day one, day two, day three videos, okay, on in the group.
Okay, sir.
Yeah, so to help you master where we are so far. Very good. Well done. So here you put in the values. Here is going to be calculator thing, honestly. Okay, I'm going to put in the value. Let me see if Millicent will still use her powers today because she's showing some magic there. Millicent, don't disappoint me. Oh. So you is 5. We are looking for t. So t plus half times 10 times t squared. This one hmm, plus 5t squared. So, but we can solve it. We can solve it with our hand, right? Divide 2
Yes.
by 4, you have 8 equals to, if you divide 2 by 5, you have t plus t squared. So, we can solve this by minus 8 equals to 0. So, this will be like factorization, right?
Yes, sir.
Yeah,
Quadratic.
yeah. We can use the almighty formula or whatever to solve it. Someone raised their hand. Oh no. Oh, Victor.
Okay.
Hello, Victor. I don't know whether the person that's bearing the name is the name showing there. Victor, can you hear me? If you are speaking, you have muted yourself, so I cannot hear you. Oh, Victor Selassie. That's the name I see here.
Hello.
Yeah, hello. Victor, welcome.
Thanks.
Victor, I can hear you.
Thank you, sir.
Okay. How are you?
I'm fine.
Guys, I'm waiting for you guys. So if Victor and I are just talking. I'm waiting for you guys to give me the answer. Me, I cannot solve that plenty thing. Is someone helping me out?
No quadratic.
Okay, sir.
Okay. Yeah. Victor, have you been able to catch up with the from the previous videos?
Only the first one.
Okay. Take your time and watch the rest then.
Okay.
Yeah. Okay. So but if you have any question, you can ask in any session at all. The good thing is that when you join the session, you can ask your own questions instead of just following the video and based on the question that people have asked and solved. So yeah. Um
Okay.
Kennedy, I was hearing you. Do you have some answers? Oh, Millicent, what's up?
Yeah.
Today this one is over. Me self, I cannot use my technique, my small technique to do it unless I get calculator. Robert and Kennedy, do you guys
Sir,
have, yes, you have something?
I had -1 plus root 33 on 2.
Plus
Root 33
33
Yeah.
on 2.
on 2. All on 2.
Oh, all of them on 2. Okay.
Yeah.
Okay, okay.
And the second
The second one is what?
-1.
Mm-hmm.
-1
Minus
minus
root 33 on 2.
root 33
So
on 2.
yeah. So can you convert it to a decimal value?
So you convert that answer to decimals.
Yeah,
So
You know, call them
it will be what?
calculator.
I'm coming.
Me, I don't have calculator actually. That's why I'm saying that you people should prepare your calculators so that we can, or you can put new batteries inside. Okay. Um. Okay. We have 5 minutes to time. 5 minutes to time. So actually, this one will give you a
So we
negative value, right? Okay. What do you have?
yeah, -3.37.
Okay, and this one will give you what?
2.37.
2.37. So which of them are we taking?
We are taking the positive one.
Yes. So right now in your scope at the WASI level, we don't take the negative value for time. So 2.37. Is this correct?
Yes, seconds.
Yeah, seconds. Yes. Unit. Me, that's how I mark my students. When they are done and they don't add units, the whole thing is zero. So the unit is very important. Let's know in what you are measuring. So let's not avoid. Let's all avoid that mistake. Okay, well done. So it's 4 minutes to time. Yeah. So this is the question I have for you guys to try. Right. Yeah, let me see. If I yeah, I would like you to guys. No, not this one. This particular one. This particular one. It's a challenge for you. You can try it on your own. Yeah, I will also paste it in the group in the channel, right? So that you can try it. Are you okay?
Okay.
Yes. So far in 3 days, we've been able to cover questions on like ranges of motions, the linear one, the linear part on ground to ground, and be able to do up under gravity, top and down. So when we meet again under physics, when it comes to physics again, we are going to do projectile motion, where the body is now projected at an angle, not just thrown up and down. That's what's going to happen in the projectile motion. Because we are done with those particular chapters, linear motion. We are done with linear motion on the ground and up and down. We are now going to move to another subject, which is going to be mathematics. So for the mathematics, we are going to do coordinate geometry one. We're going to take our time to do the coordinate geometry one as well. Very, very well. So the thing is that people also think they also understand the topic that they have covered already, or it's easy until they meet some questions in WASI and then they cannot solve it. But what gives you an upper hand is be able to understand the the concept at the core, just like how we understand for the physics so far. So that's the same thing we are going to approach for all the subjects that we'll be covering. So I encourage you guys, if you miss a session, just go and watch the video. Next time, bring your questions, and then let's all make sure that everything is clarified very well. And then in the session, you're able to engage in order to clear all the doubts that you have. Are we good?
Yes, sir.
Yes.
Yeah.
Yes.
Tomorrow is Saturday. Tomorrow is Saturday. Yes. There won't be session. Mostly Thursday and Friday there won't be session. Thursday and Saturday there won't be session. So tomorrow there won't be session. Take that time to catch up for those who have to catch up. Or maybe those who have caught up already, you can take this question that I'll put in the group for you guys to try it. And then let's see who has the correct answer next time. Now, um on Sunday we'll be starting the mathematics. That will be a new chapter, coordinate geometry one. When we are done with coordinate geometry one, we'll go to coordinate geometry two. I like doing my things in order. So, but there are some topics already that we have covered on our channel. If you go to our channel, you can see chemistry, you can see physics, you can see mathematics. There are a lot of chapters that have been covered, especially the basics ones. So take your time to go through when you are free or all that. But I will make sure that in the session we'll be able to help you understand anything that you may find difficult.